All right, hello, and thank you so much for joining us today for this week's session of the Parks College Weekly Webinar Series. My name is Amy Price, and I'm the Outreach Coordinator here at SLU's Parks College. I'm joined today virtually by Dr. Jenna Gorlewicz and her graduate students, who will be talking about their work within the Chrome Lab and the Mechanical Engineering program. We're so excited to have you joining us today from wherever you might be. Thank you for taking the time to virtually visit us and learn more about the engineering programs at St. Louis University. In total, Parks College has programs available in aerospace, biomedical, civil, computer, electrical, and mechanical engineering, as well as flight science and aviation management and physics. We hope that you'll see or hear something today that piques your interest. Before we start, I wanted to give you an idea of how the webinar will flow. In just a moment, I'll introduce Dr. Gorlewicz, who will talk about her work and the Chrome Lab. She'll then introduce current students who will share their work and perspectives of being engineering students at SLU with you. Throughout the webinar, we encourage you to submit any questions you may have to the Q&A feature at the bottom of your screen if you're viewing through Zoom, or in the comment section if you're viewing through Facebook Live. And we'll do our best to answer as many questions as possible during the last few minutes of our session. Throughout this webinar, you don't need to worry about turning off your microphone or camera. You can hear and see our presenters throughout the webinar, but we cannot hear or see you. Finally, if you have any technical difficulties during the webinar, please send an email to parksevents@slu.edu and we'll help address any issues that may arise. This session will be recorded and posted to our YouTube page in the next few days, and you'll receive an email with that link when it becomes available. So now, with all of that housekeeping out of the way, I'm very happy to introduce SLU's Chrome Lab and Dr. Jenna Gorlewicz. Dr. Gorlewicz, I will hand it over to you now.
Okay, great. Can everybody, let's see, share my screen here. Okay. Thanks everyone for tuning in today. We're extremely excited to get to feature the Chrome Lab on the weekly webinar series. So let me tell you a little bit about myself. My name is Dr. Jenna Gorlewicz. I'm an associate professor in mechanical engineering here at SLU, and I direct the Chrome Lab. Chrome stands for Collaborative Haptics, Robotics, and Mechatronics. So what does all of that mean? Well, collaborative really captures what we do in the Chrome Lab in the sense of we care about the collaboration between humans and technology. And in an age where we're all using technology, this is a really important problem, right? We want to make sure that technology is designed by, with, and for all of us. So we care very much about the collaboration at the human technology frontier. And the way we look at this collaboration is through a technology lens, specifically through robotics and mechatronics. So mechatronics refers to intelligent systems. It's systems that have mechanical and electrical components that work together to achieve some goal. And in the same vein, robotics are often smart or intelligent systems who can, to some extent, do these or achieve these goals autonomously or in a semi-autonomous way, or working together with humans to achieve these goals. And the last word that I'll talk about is haptics. The Chrome Lab is specifically interested in how we bring haptics into robotic and mechatronic systems. And so what is haptics? Haptics refers to our sense of touch. It's exploring the world, and it's the science of touch. And the Chrome Lab and many labs focus on touch because touch is something that's largely missing in electronic and digital technologies that exist today. So we're very interested in how we bring touch back. And so the Chrome Lab is within the mechanical engineering department here at SLU. And today you're going to hear from several of my graduate and undergraduate students who have worked on a variety of projects in the Chrome Lab. And I'm just going to highlight a couple of them. So we work, on the one end, we work really closely with humans. So humans are the driving force behind everything that we investigate in the Chrome Lab. And we want to learn from humans, and we want to understand the very human experience that is often missing in the technologies that we use today. So some examples of projects that we work on include designing a hockey puck for the blind, This is done in collaboration with the St. Louis Blues Blind Hockey Club. I don't know if you knew we had a blind hockey club, but we do. They're affiliated with the St. Louis Blues. And if you can think for a moment about how would I play hockey blind, I bet some very interesting questions start to come to your mind. So we're focused on developing a puck that produces auditory feedback as it moves across the ice, so that everyone can participate in the sport of hockey, including blind individuals. And then we also look at how we can expand technologies that we all use, technologies like touchscreens. I bet many of you have worked on a touchscreen in one form or another. But what you'll notice is that while we touch them, sure, we actually really have to look at them, right? We have to visually look at the screen in order to do something on them. And so we explore how we can use the touch capabilities of touchscreens, things like vibrations and sounds, and how we can combine all of this feedback together to make the touchscreen experience more touchable and thereby more accessible for everyone. And we look at this in the context of STEM education for individuals with visual impairments, but also in remote learning and digital learning more broadly. How do we bring touch back in a meaningful way so that we can all engage through multiple senses? We also work extensively with the deaf-blind community. And so you're going to see one project today that explores how deaf-blind individuals communicate through touch. And then our investigations that try to capture that human touch intuition into new wearable technologies. And so on the one end, we have the human spectrum. On the other end, we have the design of intelligent systems. And the Chrome Lab really looks at how do we put these things together to design technologies that augment and support human capability, not hinder it. We've all had that experience where we just want our technology to work. We just want our phone to work. We just want our computer to work. We just want to be able to find this spot on the website and I just have to keep swiping. Right? We've all had those experiences. The Chrome Lab seeks to address that barrier and to make sure that the technology experiences that we have are intuitive and maybe even enjoyable. And so now I'm going to turn it over to my students to showcase a couple of the interesting projects that we're working on in the Chrome Lab.
Hi guys, I'm John. I'm one of the graduate students in the lab. I am actually getting a degree in computer science as a master's, but I did my undergraduate in mechanical engineering and got into engineering to build things and to help people, which is pretty much what the Chrome Lab does, as Dr. Gorlewicz explained. I'm going to show you guys just very briefly. I help out on several of the different projects, but one of the areas that I help with is 3D printing because we use it in a lot of interesting ways in our projects. So I actually have set up in my room at home here a 3D printer that's running right now just to print a little demo print to show you guys. But it's one of the most useful technologies we found for rapidly developing different prototypes that we can use and like using those things that we build in creative ways to help people. So I'll actually pass it off to Scott here in a second just to show you guys some of the things we've done and how that can be used for our different projects.
Hello, so I'm Scott. I'm a grad student here as well. Like John, I did my undergrad in mechanical engineering, and I'm currently working towards a PhD in engineering here in the lab. A lot of what I'm focusing on is sort of what Jenna talked about collaboration. So trying to make the learning experience for students with visual impairments much better, a lot better than it currently is through robotics and through different systems. And a lot of those things start with 3D printed prototypes. So I've got in front of me here several of the prototypes that I'm working on. Essentially what these are variable quadrilaterals. So they work in that they can vary their angles as well as their lengths. And so what these do is allow a blind student to experience geometry in a different way. So currently what these students have to work with is a printed model of these shapes. And so this is embossed paper. It has texture along the edges, but it doesn't really give a full sense of variability or any kind of modularity to it. And so what I'm working on is designing these prototypes that can give a tactile feeling, a more tangible experience to geometry in order to learn different area relations, length relations within different shapes. And thanks to John's printing, I've been able to print several of these prototypes and iterations as we go along in order to make them better and better continuously. We also use them a little bit for fun. And so John's been able to print some even more impressive things, such as this T-Rex here that sits in our lab. But overall, it's been really beneficial having these rapid prototypes able to print and develop a lot of the work that we do here. I believe I'm passing off to Maggie now.
Hi everyone, so my name is Maggie. I am an undergrad. I'm a senior at SLU. I'm majoring in mechanical engineering and I worked with Chrome Lab for I think 2 years now, which is really exciting. The main thing that I've been working on during my time here has been working on digital tactile graphics. And kind of like what Scott was saying, they are for blind or visually impaired students, and in order to get them to understand information more easily and in a more portable fashion, because right now they work primarily with embossed graphics, like on the paper that's all bumped out and everything. And that's really difficult for teachers. It's very time consuming, it's very expensive, and it's heavy and bulky. So if we could manage to get those tactile graphics onto a tablet that the student could just carry with them, their learning experience would be a lot easier for everyone involved. So that's why we've been developing these graphics. There are bar graphs as well as geometric figures. I'll show you the geometry in a minute. But how these work is the student would be able to
count 50 and bar count 25 and bar vegetables.
These, and it reads out the data axes and the
count vegetables
and the count of each of the bars.
Count 50 and
So
bar
this would
vegetables.
be someone trying to understand how many people eat vegetables versus how many people eat fruit. And so you could
Count 0 vegetables, fruit,
and the vibrations are different for each of the bars. And then you would stop and
count
double check,
43
and it tells you the count.
food results.
So a blind or visually impaired person would be able to explore this graph and understand that data just by audio and haptic feedback, which is really, really great because then they wouldn't need the embossed graphic at all. And there are several versions of this where you can explore.
50%.
And then once we get through those, we can move on to the geometric figures. So this triangle, they would be able to explore it
Diagonal C,
just by feeling through
vertex I, angle
each of
I,
the vertices,
angle I,
reads
100
out
degrees between line B and lines.
the
Angle
value
C,
of the
40
angle.
degrees between line I and line B.
And each of the lines has a certain title and tells you where it is with respect to the other features, like the different degrees of the angles and the different lines that you've already understood. This one is fun because there's a different sound for a right angle, which is really, really helpful for people to understand what the shape looks like.
Vertical C, W, 16 centimeters, 90-degree angle. Vertex C.
So that ding means that you've reached 90-degree angle. So these shapes are really, really helpful, and they make it easier for the student to learn and makes it easier on the teachers to teach them. In addition to those graphics, we have also been working on having these simulations that help them understand concepts and not only information that's written out. So this is John Travoltage. He is a FETSIM, so you can manipulate him by rubbing his leg on the floor and the phone vibrates so that you understand that something is happening when you can't see. And then when you move his arm around, it makes a noise and all of the electrons go to the doorknob. Like that. And it vibrates and makes a noise. So you understand more in a holistic tactile sense of what static electricity is, because you can feel it bubbling up in him as you move his leg on the carpet, and then you feel the zap and hear the electric sound when the static electricity is produced by touching the doorknob. So it helps to really underline the concept. So that's a lot of what our digital tactile graphics do. I believe now I'm handing things off to Brian.
Hi, everyone. So I'm Brian. Like Scott, I'm a graduate PhD student in the lab here. But I work on something a little bit different than everyone else. I do wearable haptics. So in conjunction with the deafblind individuals that I've met with in Seattle and all around the US, we work together to create more realistic sensations through the sense of touch. So pressure, vibration, heat application, all those things, but combined into something that you can wear. So that way, in a remote sense, I can be able to communicate with someone, but not have to speak or for them to hear me. So, because if you're deaf and blind, you live through the world of touch because you don't have your sight and you don't have your hearing. So as a little bit of a demo, I can show you guys a couple of the parts of this. So the back of the hand is a whole bunch of vibration motors. And we can do things where like, we can give directions through them. So like different orientations cause different sorts of sensations. So I can have like a more general vibration across the whole hand. I can have pinpoints on certain parts of it. And then on the sleeve part of it, further down, I have a whole bunch of these little motors here, and they can tap and give sort of like directional cues as well, saying like, oh, you're approaching something, or they can like tap as like, oh, hey, yeah, I'm listening. So let me give you a quick example of what that would look like. So you can see they all just activated, went right down the line, just in like a tracing manner. It's like someone was sitting there and doing this with their fingers. I can do something where I can say, oh, just like single taps, all sorts of different things. And it's these different cues that then build up and create like the building blocks of communication. And so with that, I will pass it off to Evan for the final part.
Hi guys, I'm Evan. I am an undergrad in this lab. I am studying biomedical engineering at SLU, but I have a large interest in robotics and mechatronics, which is why I'm on this project. So I work with this telerobot. His name is QB, and I work on a project team with 2 grad students for that. And so I'm definitely not doing this all alone. I have a lot of guidance as an undergrad, which is very helpful in developing my skills for sure. So this telerobot project, basically what we're doing is we're adding an arm to a telerobot. So telerobots are those robots that go into like businesses, so remote workers can kind of video call in, but also be able to move around in the space. And especially nowadays, with all of this virtual working and virtual learning, this is a very important market to address. And one thing that's definitely missing from that is the ability to interact with people on a more tangible level. So shake hands with them, wave to them, high five people. And that's definitely something I know we all are missing with the amount of virtual learning and working that we've been doing lately. So this will hopefully address that. And so the arm that I'm working on, it has 6 motors in it. 1, 2, 3, 4, 5, and then 6 there. And it has 5 degrees of freedom. There is shoulder abduction, shoulder flexion, shoulder rotation, elbow flexion, and wrist rotation. And this new arm right now is not running, but because I just built it. I just designed all of these components, and now we're doing some software integration on it. But I can show you a video of the old arm that we have, so he can give a little wave to you. Let's see. And so as you can see, there we go. Now you can see. The remote arm follows the hand of the user. So you would have someone at home who has this tracking system and glove on, and they are controlling this robot, and the robot is basically mirroring their movements. So it does what you can do, and therefore since we have a very robust system on it, it can even do contact interactions like handshakes and high fives without breaking the arm, which is something that a lot of social robots nowadays have trouble with, is those tangible interactions. So yeah, that's what I'm working on. And I think we are gonna open it up for questions now. I'll send it back to you.
All right. Well, thank you all so very much for showing us these various projects. I will ask everybody, all of our presenters now, to turn on your cameras. We do want to open it up for some question and answer time. So if anyone has a question, please submit that to the Q&A feature at the bottom of your screen if you're on Zoom, or if you're on Facebook, throw it in the comment section. But a question that we get a lot about this lab, there's so many projects that we can see in our day-to-day lives, and we could see them being used regularly. So what happens beyond the Chrome lab? Are there patents coming out of this lab? Are these prototypes being used in real time yet in everyday people's lives? Or what's next for these projects, I guess?
Okay, I think that's my question to take. So I'll take that question. So there's a lot that happens, and I would say there's even a lot that happens within the lab. So like the graphics that Maggie showed on the touchscreen, those have been created in partnership with schools in the local region and with residential schools for the blind across the country. So I think the Chrome Lab takes a very cognizant approach of involving the end user in the beginning, so that the designs and the products and the innovations that we're coming up with have the chance to have some meaningful impact beyond our lab. And I'll stick with the touchscreen project for just a bit. An example of how this has gone beyond the Chrome Lab is that I have an ed tech startup called Vital, which has taken some of the fundamental technologies that we've developed in the lab and made them into a commercial product. So there's a software where teachers can go in and annotate the images that Maggie was showing, so that they can assign vibrations or assign tones to the images in the way that students would prefer it. So everybody likes something different, right? We all choose different ringtones or different vibrations. We all have different preferences. And so the purpose of the content creator platform is that we can create these multimodal images in a personal way. And then there's a student-facing tablet app where they can go on and feel the images in near real time. So not having to go and run to an embosser to get these tactile representations in some form. So yes, there's patents, there's startups, and then there's just releasing it so that folks can use it.
That's great. Thank you. Yes, there's just so much going on. It's very exciting. We do have a question that came in. If we could go really quickly around everybody and maybe answer in the order you presented, but what's your favorite part of the Chrome Lab? And what's your favorite robotic project that you've been involved in? So if we can just go around really quickly and give us your feedback.
I think my favorite part of the Chrome Lab has been getting to interact with so many different projects that are all focused on helping people. It's cool to have like a variety of different things you can work on and touch that are all headed towards like the same good goal. But probably my favorite one that I've worked on so far is the one that I'm working on with Brian right now with the haptic sleeve. I think that's been a fascinating project.
For me, I really like the invention aspect of working in the lab. A lot of these designs, all of these designs I've made myself and printed and then iterated through and worked on. And so that's been really exciting, just that discovery process. And in terms of robotics, John and I had a few in undergrad a few different projects that we really enjoyed, of programming robots to dance to songs and stuff, which we really enjoyed. And so those have been really fun. And those were just here at SLU in our undergrad.
I think my favorite part of the Chrome Lab is the hands-on experience that I get and all the skills that I've learned. I know at some places, a lot of undergrads don't get to like build those skills during their time in undergrad. But I really love being able to interact with people who obviously know a lot more about this than I do because they're in grad school, and I'm able to pull from a lot of resources, and that they trust me to do things on my own, and I get to learn how to program and do things in CAD modeling and work user studies on my own. Like that kind of like skill is really, really fun. And as for my favorite project, I don't know that it counts as robotics, but I really love working on this 3D printed case to go over the tablet that houses the digital graphics. It's really fun and it's really interesting, and it is I think it's going to be a super helpful tool for people who are eventually going to be able to explore the graphics.
I would say that probably my favorite part of the lab is just the people in here, honestly. There's not anyone that I wouldn't enjoy having like any sort of project partnering with. It's been quite an experience really in the last year and a half that I've been here. Jenna's done a great job putting together this awesome team, and we all have such really interesting, like unique projects that we can talk to each other and never get bored with what everyone's saying. There's always something interesting going on. And in terms of favorites when it comes to projects that I've done, honestly, like the sleeve that I've been working on is fantastic. I got the unique experience of being able to go out to Seattle and meeting with the deafblind community there and actually seeing how they communicate with each other, which is just absolutely wild. And Jenna and I both got the chance to do that, and we had to go an entire weekend without speaking, which was a really interesting experience. But I'll pass it off now.
Yeah, so I do a lot of robotics, and my favorite part of the Chrome Lab, I'll start with that, is definitely the resources that I have here. So I get to consult all of these different grad students and undergrad students because they're all really good at different things. And so I get to kind of see what they're good at and how that applies to my project. And I have definitely had very useful conversations with everyone here. And my favorite part of like this robot project specifically is recently this new arm. I did like the whole mechanical design of that. And I definitely focused on the mechanics of this project rather than the computer science. And so I get to look at stuff like motor torques and velocities, and then how I'm going to stabilize the system and make sure it's balanced. And I also, most of these components on here that connect the different motors are just 3D printed components. So I got to model those in CAD, and that was just a really fun time for me. But not everyone's interested in the same nerdy stuff that I'm interested in, but like just sitting on CAD all day, like I love just modeling and designing and drawing and then seeing it become like a 3D thing. And then as far as like getting into the Chrome Lab, like courses and classes to take, I started taking some engineering classes that my high school offered called Project Lead the Way, and that really got me into engineering. And then once I got here, it was a lot of the engineering classes determined by my biomedical engineering major, but I wanted to do more with mechanics and robotics, and so I jumped at an opportunity that I saw posted from Dr. Gorlewicz and started working in the lab.
Excellent, excellent. And Maggie, can I put you on the spot really quick? As also an undergraduate student, did you come about your position in the same way?
Yeah, absolutely. So my path to engineering as a whole was a little bit different because I didn't realize that I was interested in engineering until really late in high school. So I didn't have the high school background. But once I got here, I sort of started looking at it holistically to figure out what part of mechanical engineering I was interested in. And it was a lot of process of elimination based on my classes. Like I would take thermodynamics and we talked about engines and cars, and I realized that that is not the area that I want to go into. So we started looking at more things like airplanes, and I knocked that off the list. But then I just kept narrowing it down. And then I heard about this lab and how they have such a great emphasis on human robotic collaboration and all of the different technologies that they develop and the variety of projects. I thought it sounded like an amazing place. And just similar to Evan, when I got the email announcing an opportunity from Dr. Gorlewicz, who also happened to be my faculty mentor, I was so excited and just jumped right on it.
Oh, that's great. The stars aligned. Yes. Now, in just our last minute, Dr. Gorlewicz, could you just provide us any advice that you would have for high school students that might be looking at an engineering degree and then maybe hoping for a spot in a lab like yours? What advice would you have?
Sure. I think my advice is to not be afraid to try it. So I didn't have a clue what I wanted to be in high school, and I switched majors halfway through college. And engineering was probably the last one on my list, and not because it wasn't a great area, because I really didn't know that much about it. And I really wanted to end up in a spot where I thought I was going to be helping people, and I didn't see engineering as that career path until I got into college. And so I would say, consider engineering as a potential career opportunity where you do get to help people. It's not like I'm directly working with patients in a medical setting, but you can see the benefits of the impact that the projects that we're doing are going to have on lots of different people. And my favorite part of the research that we do is working with the people to design those. And so, as a high schooler, I'd say have engineering on your radar. Know that it can be a way that you can help people, and don't be afraid to join that robotics club or join that STEM project or participate in the STEM fair or the STEAM fair and try it out for yourself.
Excellent. Thank you. Well, I want to send a huge thank you to Dr. Gorlewicz, Brian, Evan, John, Maggie, and Scott. Thank you for sharing your time with us and sharing your research and projects with us. I also want to thank our attendees for joining us today, and we hope that you did enjoy this virtual visit to SLU's Chrome Lab. If you would like to learn more about the engineering programs at SLU, please visit slu.edu/parks. As always, you can reach out to us at parksevents@slu.edu. if you would like to connect further. And finally, this is the last session of the Parks weekly webinar series this semester. We are looking forward to providing additional content about our engineering and our aviation programs and opportunities to connect with you more in the spring. So please keep an eye out for an email with those details when they're available. So once again, thanks for joining us and have a happy and safe holiday season ahead.